In this video, I'm going to explain about interrupt IO. Okay, so in my previous video, we discussed about what you mean by IO communication techniques and how communication will happen between the IO devices and the processor using program controlled IO. Okay, so in program controlled IO, processor through a program keeps checking the status of the IO devices whether it becomes ready or not. Whenever IO device becomes ready, it will do the data transfer with that. It will involve in the data transfer. So suppose if that IO device is not ready, it keeps on waiting. So that is the major disadvantage of this program controlled IO. That means if the processor check the status and if it is not ready, if it is 0, it will wait until it becomes ready, and then if it is ready, it will take the data and again wait for the next data. So we are making processor to wait for a long time, and it instead of doing useful computational work, our processor is keep checking all the devices are ready or not ready or not ready. Simply just checking. Okay, so for that I have given the example in the classroom. So the teacher, instead of teaching, so it's simply checking. So which student is having question, which student is having doubt, like that is keep asking all the students. So this is what the disadvantage. So the disadvantage of that is overcome by the interrupt IO that I am going to discuss in this video. Now in the interrupt video, instead of processor checking all the IO devices ready or not, now what we can make, so we can allow CPU to do useful tasks, some computation work, let it do some work, a task they keep executing. Whenever any IO devices is ready with some data for the data transfer, that IO devices itself informs the processor saying that, so I am ready for the data. So instead of, so again coming to the example of the classroom, instead of teacher checking his student is having good, the teacher is continuing delivering the content, is teaching. So whenever any student is having any question or any doubt, so student only informs the faculty by raising the hand or by doing some signal. So in the same way, so we need to make an arrangement in such a way that IO devices should signals the processor saying that it is ready for data transfer. So once CPU will get signal from the IO devices, it stops executing the current task and takes up the call. So this is the concept behind the interrupt IO. In interrupt IO, whenever any IO device is ready for data transfer, that IO device informs the processor by sending one signal. Okay, the signal generated by the IO devices to processor is called interrupt. Okay, so thus we can say interrupt is nothing but an hardware signal. Hardware signal generated by what? Generated by the IO device, to whom it will generate or send to the processor. Okay, so that is what that means. Whenever IO device is ready, that particular IO device sends some signal to the processor. The signal what it sends, so that is called interrupt signal. Okay, so interrupt is a hardware signal generated by the IO devices to the CPU requesting for some service. That means whenever an IO device sends some interrupt, so that is ready for data transfer in different ways. So at that time, CPU will stop its execution and it will take that interrupt service and execute the corresponding interrupt service routine. And after completing executing that interrupt service routine, again it come back to the where it was stopped earlier, it will comes back and it will resume from there. Okay, this is how it will work. Now, whenever CPU receives that interrupt signal, so this IO devices sends this interrupt through one line called interrupt request line. So that is one control signal. That means we know that bus, three types of buses: address bus, data bus, control bus. In the control bus, there are many lines are there. Out of many lines in the control bus, one control line is used to send the interrupt signal. Okay, so we'll call this as an interrupt request line. As the interrupt request, it will send interrupt request. Upon receiving this interrupt request, now processor will send one acknowledgement back to the IO devices saying that I have received your interrupt, I'm going to service your request soon. Okay, so that is interrupt acknowledgement. Interrupt acknowledgement, it will send back. Okay, now assume our processor is executing some instructions. Assume when it is executing, say, let us take first instruction, second instruction. So like that, when it is executing that ith instruction, assume interrupt occurs. Okay, here interrupt occurs. When interrupt occurs at the ith instruction, so now again, after that I'm having so many instructions. Okay, now whenever interrupt occurs at this instruction, ith instruction, now our processor stops execution and it goes to the corresponding interrupt request interrupt service routine, and it completes that. After completing all the instructions of the interrupt service routine, again it comes back exactly where it was stopped earlier, and from there it was resumes. Okay, for example, assume you people use this concept already in your daily life. Assume you people are watching some video in our mobile. Suppose while you are watching video, so assume your parent called or somebody called. Now when you got a call, you are watching movie. So whenever at that time some interrupt occurs on call come, it stops there only, and now we need to attend that one. Attend that call means either you have to receive the call or you have to decline the call, reject the call. That means after attending the call, again exactly the processor come back exactly where we stopped that video, from there call resumes. So that is the interrupt concept. Okay. Now the question is, whenever interrupt occurs, okay, so that is IO devices raise the interrupt. There are many IO devices are connected. So how only one IO device will send? So that's the question. Because when many IO devices are there, any IO devices can raise the interrupt at any point of time. So how to identify? For that, so whenever CPU is doing its task, it will make all the IO devices one task enable. It enables all the IO devices to raise the interrupt. Whenever any one IO device sends the request through that one interrupt request line, it disables all other IO devices until it completes the service of that particular IO device. After completing the service of that particular IO device, again it enables other IO devices all interrupts. It enables. So then like this, CPU will enable and disable the interrupt request lines of all the IO devices. This is how it will done. Okay. So hope you people understood the concept of interrupt IO. Interrupt IO. If you are not subscribed to the channel, please subscribe to the channel. Please inform your juniors or share with your juniors and friends. If you have any questions, please write in the comments. Thank you. Thanks for watching.